Hey folks, back. It's been a little while since I've done a video. I want to do a quick shout out to Jose Torre or Torre. I'm not sure how you pronounce your last name, but Jose, I appreciate the response in regards to relays, and that's what we're going to do today is one on relays. Relays are a way of controlling high voltage or high current devices or circuitry with low voltage and low current circuitry. In your automobile, you'll have relays in there for the air conditioning relay and stuff. You have 12 volts DC, very low current that's operating the relay, because your compressor, when it comes on, has a very, very high current for the inrush on that. And so that the contacts on the relay can handle that higher current, but you don't need that. It's like I was talking about earlier in one of my videos. It's a midget that's riding a Clydesdale. The Clydesdale is doing all the heavy work. It's the one who's lifting and pulling and all that stuff. That little midget, all he's doing, he's just barely giving a little bit of reins to that horse, or telling it to go forward or stop or turn left or turn right. He's not doing any real physical heavy labor, and it's the same concept with this relay. So to clear up some confusion, let's just do a quick orientation on the relay itself. In electrical drawings, when you see a dashed line like this, that's telling you that is inside of a cabinet or inside of a container of some sort. Okay, so this here is our armature. Okay, typically you're going to see A1 or A2. You can see there's NEMA and there's IEE terminal numbers. A1 and A2 is easier to remember. It's an armature. If you see A1 or A2 on a motor, single phase motors, that's an armature for part of the motor's contact. You see that on motor contactors, you see that on relays. So that it means an armature. So that means there's going to be a coil involved with it. So this is your A1 and your A2. And I'm only doing, typically these relays will come in, they can come in big heavy duty industrial relays. They can come in little tiny ice cube relays. If you look on your car and you pop the fuse block cover on there, you'll see those little black 1 inch by 1 inch squares. Those are relays also, okay? But normally those will have 2 sets or 3 sets or 2, 4, 6 sets of contacts on it. I'm only showing you one set today just to keep things from being confusing, okay? So you'll have a common terminal going in. You'll have a normally open terminal and a normally closed terminal. So that's what the NO and the NC stand for, okay? Now I've given this 2 different colors so you guys can see the difference. The common provides power all the time. It'll always have power, whether the armature has been activated or not. There'll always be whatever voltage you're trying to control, okay? Now, when you come over here to this side, this normally closed is going to be energized also with whatever voltage you have on the common, okay? But there will not be anything on your normally open until your armature has been, the electromagnetic force of the armature has been made, and the armature closes, and then this will change state, and this will break this contact and will make this contact. So now power will come through the common up here to the normally open and power whatever that is, and it'll break this one on the normally closed. Remember, on your electrical drawings, they're drawn in their normal de-energized state. So in a normal de-energized state, there's no power to the coil. That means the normally closed is always there. There's going to be a spring involved that always closes this piece right here. On the armature, this will be attached to this. When that coil activates and it pulls this in, it'll change that state of that coil. Now, to clarify some misunderstandings that some folks have, the voltage on this right here has absolutely no bearing on the voltage here. Those are 2 completely separate independent voltage sources, 2 separate circuits. So if you put 24 volts DC in an industrial contactor, if you got 24 volts DC and you don't have anything here, nothing's going to be energized going the other way. And on the same token, if you've got your 24 volts DC here, and it can be AC, it doesn't have to be single phase. These contactors will do 3 phase and stuff like that. But if you have power here, that doesn't mean you have power here. Okay, so when you're getting into troubleshooting, I'm going to do a video on troubleshooting also with that. But these are two separate independent circuits, and they have no bearing. They're mechanically interlocked, but they are not electrically connected. Okay. You can have whatever your low voltage in industrial applications. It is typically a 24 volt DC, but it also can be 120 volt AC. You'll also see 24 volt AC. That'll throw a wrench in the machinery if you're not used to working with the 24 volt AC, because you'll get some really weird numbers on your meters. You'll get some weird numbers if you get anything on your clamp meters and stuff like that. You'll blow light bulbs up because you go put a 24 volt DC light bulb in there and they don't last. It doesn't work, and it'll just cause you some frustrations with that. So just be aware of that. But this, you could have 24 volts DC on this, low voltage, low current, and be controlling 277 volts AC, which is 480, one leg going to a neutral. And you'll see that a lot in industrial lighting in particular. Okay, so the relay, they come very, very small, about the size of this lighter. Those are typically referred to ice cube relays. They'll be typically a clear plastic. You can see all the workings in there. You'll see the coil. You'll see the little contacts and everything. Some of them get pretty doggone big. As far as, the ice cube relay, they're still clear, but they might be 2 inches tall and 1 inch by an inch square. Those will have a round socket with pins. The ones that are like this, they'll typically, not a lighter, but just at that size, they'll have small flat pins, male flat pins that go to them. And then you'll have big industrial contactors. They look like a motor contactor. If you didn't look right at it and look at the terminal numbers that are on that thing, you'd think it was a motor contactor. But those will handle the 480 volts, your 208 three-phase, and it'll handle high current, with motors or light switching, industrial light switching, heater contacts and things like that. Okay. I hope this answers questions. I hope this makes things more clear. If not, shoot me, make a comment down below, and I'll be glad to answer the questions for you. And be honest with you, please don't. There's nothing that's silly. I was a teacher for a long period of time, and guys held back and they didn't understand something. Because the key thing, if you're getting into this industry, you have to understand how these components work. Otherwise, you're not going to be able to troubleshoot very well. You'll be a parts changer, and parts changer is the lowest form of life out there in the maintenance world. That's a guy who does not know what's going on. It's one thing to be ignorant that you don't know. It's another thing to be willfully ignorant where you refuse to learn. Okay, and I enjoy teaching. I enjoy exposing guys and answering these questions. So please don't hesitate to ask a question. I'll be happy to help you out. Other than that, be safe out there, and I'll see you next time.